Hi guys, this is for module 4.1, angles formed by intersecting lines. Our essential question is how can you find the measure of angles formed by intersecting lines? The answer, or the shortest one I can give you, is well, first off, we need to identify any known angles. So if you see a right angle, make sure you note that. You see a straight angle created by a straight line? Yeah, that's something to note. Look for pairs of vertical angles, okay, and we'll get to that. That is, by the way, our new word, vertical angles, our new definition, okay? And linear pairs of angles. So real quick, linear pairs, if you remember, here's our intersecting lines like they're talking about. Here's angle 1, and here's angle 2. Those are linear pairs, okay? And also, by the way, they do, if you notice, they both share this straight line that I'm indicating right there. That means that angle 1 plus angle 2 should give us 180 degrees, okay? Because they're linear pairs and they share the same line. All right, definition of a straight line anyways is 180. So that's like a fun fact. All right, something to take note of. All right, also notice if you have any complementary or supplementary angles. That's always good to know as well. Okay, remember complementary add up to 90 degrees. That's something to note. Supplementary 180. If you always mix up the two, just remember C becomes is C in the alphabet comes way before S. So C 90, which comes before 180. So it's just kind of like least to greatest, except with the alphabet. All right, definitions. Vertical angles are when two lines intersect, the angles that are opposite each other. So basically, here's our two lines intersecting each other. Okay, they're crossing one another. You could try this with almost anything in the real world. And basically, all it's saying is, well, let's say angle 1 is here, angle 2 is here, angle 3 is here, and angle 4 is over here. Let's say angle 1 is the vertical angle of angle 3. Basically, they're just right across from each other, and that's something to take note. Okay, another vertical angle, or pair of vertical angles, would be angle 2 to angle 4. So that's something to notice. That's what they're talking about in the sense of the definition. It's basically the guy right across the intersection. Okay. Flow proof is another type of proof that uses boxes and arrows to show structure of the proof. I'll show you one today. Basically, it's like, we make our statement, blah, 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 and we explain why, given, all right? Then it goes to your next statement, blah, 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 and then your reasoning. Maybe it's a theorem, okay? And that's basically what you're doing with a flow proof. That's the general idea, okay? I didn't really do those in college, but I'm going to show you an example and we'll play around with it as we go through. Yeah, we usually use paragraph proofs or table, T-chart proofs. All right, moving on. Vertical angles theorem. All right, so if two angles are vertical angles, then the angles are congruent. Good to note. So remember when I said vertical angles are basically the guys right across the angles that are right across from each other on the intersection? So angle 1, okay, will be a vertical angle to angle 3. Now, fun fact, the theorem basically just says angle 1 is going to be congruent to angle 3. So if angle 1 was 40 degrees, angle 3 would be 40 degrees. Okay, so that's something to note. Now, also notice that 1 and 2 are sharing, basically, they're sharing linear pairs, right? So angle 1 and 2 are linear pairs. And they also share a straight line, so they should add up to 180 degrees. And to find angle 2, we would know that, well, we have 40 degrees already found. Angle 2, well, what's 180 minus 40? And that'll get you the other pair, or linear pair, okay? Now, if angle 2 is 140 degrees, well, fun fact, because of the theorem itself, which says that angle 2 is going to be congruent to angle 4 has to be 140 degrees. Okay, so remember the linear pairs, angle 1 and angle 2, both add up to 180 because they share a straight line. But since that happens, and we already know that angle 1 is 40 degrees, basically we just do some quick algebra with the good old subtraction property. There we go. And that's how I got the 140. So angle 2 equals 140. Okay, so that's about it. All right, now let's go on to proving vertical angles. So follow the steps to write the plan for proof and the flow proof to prove the vertical angle theorem. So we have this theorem, but where did it come from? All right, so you heard me rambling on about how angle 1 and 2 are linear pairs. That's actually a part of the proof. Okay, so we're going to start off with this. First, they give us that angle 1 and angle 3 are vertical angles, and that's visually acceptable. Angle 1 is across from angle 3 on that intersection there, therefore vertical angles, right? So that was given. So basically we start off with that. Angle 1, oops, sorry, and angle 3 are vertical angles. Okay, and that was given. And then after that, there are two situations that happen here. Angle 1 and 2, again, are linear pairs. That's interesting. Well, isn't angle 2 and 3 also another pair of linear pairs, right? So let's do this. I'm going to break away here. I'm going to address angle 1 and angle 2 being linear pairs. And that's basically just because, the diagram itself, or by the definition of linear pairs. And I'm going to say the same thing about angle 2 and angle 3. Okay, angle 2 and angle 3 are also linear pairs. And then again, that was the definition of linear pairs. Now, what do we know about angle 1 and 2? They both share a straight line. That means they should add up. All right, their sum should be adding up to 180. Okay, so we would say angle 1 and angle, or I'm sorry, let me erase that real quick. So angle 1 and angle 2, so we should add them because they are supplementary. So angle 1 plus angle 2 equals 180 degrees. Okay, and that's because the definition of a straight line. Okay, now I'm going to say the same thing with my other linear pairs. So angle 2 plus angle 3 equals 180 degrees. Now, same reasoning, definition of a straight line. Okay, straight line, or this is also complementary or supplementary angles. Apologies. These are both supplementary angles. So you could also say a definition of supplementary angles, and that would work just fine. Now, what we notice is they both add up to 180, right? So we know that if we converge these two, angle 1 plus angle 2 should equal angle 2 plus angle 3, right? Because they both equal 180. Now this is actually the transitive property. So transitive property is making its way back. Okay, remember the transitive property? If I high five and best friends with somebody else, right? So here's me, and or here's my friend, okay, and then here's me, and then here's another one of my friends. We're best friends, high five, yeah. We're best friends, high five, yeah. And most likely by the transitive property, my friends are probably going to get along, right? So that's the transitive property. So now, if angle 1 and 2 add up and equal angle 2 and 3, what do we notice? If we were to use the subtraction property, all right, and subtract the angle 2 on the left-hand side, right, angle 2, what do we do to one side? We have to do the other. Oops, sorry. That's a subtraction right there of angle 2. They cancel out. So all you're left with is angle 1 is going to equal angle 3. Okay, and again, that was the subtraction property of equality. Okay, so there you go. That's the actual proof. Now, as you can see, it's a bit messy. Flowcharts can be pretty messy and tedious, but that's basically the thought. So angle 1 and angle 3 equal each other, but in this sense, angle 1 is congruent to angle 3. So that would be better well said. Okay, and that would be the end of the flow proof. All right, so in example 1 in real life, I've actually made about $400 doing this for a buddy. He was welding and he was trying to put a cross beam on his bike's frame. It's good money, and he wanted to make sure the math was set, and I had to teach him about this, a couple other things as well, but he had this one measure, and he wanted to make sure that this measure was exactly, what it was. So I basically explained, well, you have vertical angles here. For example, you measured 146 for this one angle. That means your vertical angle, meaning the angle that's across from the intersection, is going to be the same. It's going to be congruent, and that we have a linear pair here. Okay, so 146 plus angle 5 should equal 180. Okay, so I just go ahead and use the subtraction property. Good old algebra kicks back in. And then we just have angle 5 equaling 34 degrees. So guess what? We also have another vertical angle. Angle 5 and 7 are vertical angles. That means angle 7 is also going to be 34 degrees. So it was a good little, geometry lesson for a biker. And the biker, he appreciated it. We welded those pieces, and he made money, and he threw me 4 Benjamins just to help him out with his angles. So believe me, you don't want to mess up on angles when you're welding. It is messy. All right. Example 2. The measures of two vertical angles are 58 degrees and 3x plus 4. So now we just have to find the value for x. So basically, they're saying here are your vertical angles. You have 3x plus 4 on one of your vertical angles, and your other vertical angle is 58. Well, we know that these are vertical angles, therefore they have to be congruent, therefore they are same. So we set them equal to one another. And then just solve for x. So I'll use a subtraction property. Okay, and I believe this is 18. Division property, x equals 18. Done. All right, your turn number 1. So again, you have two vertical angles. I'll draw the diagram for you with these expressions. All right, so let's say this guy is 2x minus 7, and his vertical angle across is x plus 3. All right, now they ask you to find the value of x, but then they also ask you to find the measure of each angle. So not only find x, but also find the actual measurements. So that means plug it in, right? Plug it in, plug it in. All right, using supplementary and complementary angles. So this is kind of the answer, going off the answer from the essential question. Basically, we have a diagram here, and they give us a whole bunch of lines intersecting one another, but from those lines come angles. So they do tell us that angle CFD, apologies, is a right angle. It's 90 degrees. But we also know that AD is 180 degrees. So this whole guy should be 180 degrees. We have 90 here. They give us the 50 here, which is very useful. So what's 180 minus 90 minus the other 50? You should get 40. And that'll be the angle for AFB. Okay, so AFB should be 40 degrees. So notice how I'm just using, it's like a puzzle. They gave me a certain amount. I know the definition of a straight line, and straight lines have 180 degrees. They gave us the 90, they gave us the 50, so just remove that, all right? Find the missing piece. Now, vertical angles should kick in. I noticed that this guy is a vertical angle to angle DFE, so this guy should be 40 as well. And they're also asking me for AFC, which is kind of funny because we all know that AFC, well, if you notice, AFC is right here. Um, that should just be another 90 degrees, right? Because the other half is 90 degrees, so 90 plus 90. So AFC should be 90 degrees. Okay, so notice how I'm paying attention to the idea of the supplementary, okay, the 180 idea, with the complementary, the 90 degrees, okay? Because I knew two 90s make 180. So notice how I was just kind of bouncing off those ideas of those two types of angles. And I even used vertical angles, right? Vertical angles right there. So just be aware of all the different types of angles you can work with. All right, your turn number 2. So use the diagram below to find the missing angles. Find AFB. All right, this guy right here. Again, think about supplementary, complementary. See if you can figure out vertical. And then lastly, find me BFA, which is kind of funny because it's the same angle. Tell you what, just to see if you're paying attention. It's not BFA I want you to find. Find me angle DFE. There you go. All right. Thank you guys. Have a great day.